Okay, hello all. I welcome you to this another video lecture in the series of computer system architecture, and in this lecture I will discuss the DMA in very simple words, and this video is going to be a very short video, and in 10 minutes I will explain the whole concept of DMA. So let's start. DMA, the full form is DMA is direct memory access, right? So direct memory access means the memory is accessed directly by the IO devices or peripheral devices, right? It means the memory is accessed directly by the IO devices, right? So for this, right, so whenever this is the scenario, when the memory is given, okay, or accessed, or is given to some devices which are the input or output devices. So in that case, this scenario or this process is known as direct memory access. And why we need the DMA? Because sometimes the speeds of the input and output devices, IO devices, and the memory and the CPU are not matched. तो जब भी जो मेमोरी मिसमैच जो स्पीड है CPU और IO डिवाइसेस की वो मिसमैच होती है. सो in that case to solve this we need DMA, direct memory access. So it is done through the DMA controller, right? So DMA has a DMA controller, DMAC, okay, direct memory access controller, and this controller has three parts. I will explain everything in the diagram also, but for the just to cover that what is DMA and what is DMA controller, what it contains. So DMA has three registers. One is AR, which is your address register. Second is your word count register, and a control register. Word count register and your control register, right? Control register. So basically address register holds the address, right? Holds the register to specify the desired location in memory. So address bits go through bus buffers into the address bus, right? Because the memory transfers and everything between the CPU and IO devices is done through the buses, as we know from the block diagram of the basic computer architecture. So this is the bus is a way to transfer something from the CPU to IO devices, and assigning memory and all that is done through a medium, which is your address bus, right? Okay, so this address register holds the address, right, where or we have to place the bits in the memory. So at that address is held by the address register. Okay, so it holds the address, right, or it stores the address, right? It stores the address in address register. Then this is word count, right? So word count register is nothing but how many words, okay, we have to transfer, or we have to transfer into the memory, means we have to place into the memory. So how many words are there in that content, okay? So this is your word count, right? Word count. And the third is control register, right? So control registers is specify the mode of transfer, okay? The mode of transfer means it is directly or indirectly or whatever. So the control register specifies the mode of the transfer. It specifies the mode of transfer. Specify the mode of transfer. So let's see how it is done, okay? How it is done actually. So we have a CPU, right? We have a CPU. We have a DMA, right? This is your DMA, and it's come into the picture when we have this when the speeds are mismatched between the CPU and IO devices, right? So and DMA has three things, which is address register, right? Then we have word count. Then we have a control register. So when you draw this black diagram, please mention the full form of these three addresses, three address registers on the right or left hand side whenever you want. So that will be clarity that what is the TM and what are its contents, okay? And then we have here IO devices. Here we have memory, right? So as we know, CPU is the brain of the computer. CPU has all the power and CPU has all the control over the memory and the transfers of this buses through the buses, right? So here we have the memory, right? Here we have this DMA, direct memory access control, right? Okay, let me connect with this, right? So to understand the things, right? So firstly, what happens? IO request, right? IO request to the DMA to allow me to transfer between this to allow access to the memory, okay? To allow access to the memory, right? From here to here, right? So this is allowed when the input and output devices request to the DMA, and DMA, because DMA has no power, it requests for the CPU that for allowing means allowing DMA to control this memory access. So it holds, okay, it holds for the some time, right? And when it gives permission after giving the acknowledgement to back to the DMA that yes, this permission is granted, or you can do, right? You can access the memory. I am acknowledging you, okay? And then the DMA send this message back to the right here, granted, right, back to the IO devices that the CPU, I have taken the permission from the CPU that you can initiate the transfer, okay, initiate the transfer or initiate the access, right, or access to the memory directly. So this is the whole scenario of the direct memory access. Okay, so let me repeat the role of these three registers, so you cannot forget about this. So address register, it has the address, right? It has the address where we have to access or what we have to access in the memory. So this is the address. Okay, then a word count register, it means that how many words, right? Okay, so word count register holds the number of words to be transferred. So what is the size of that कंटेंट ऑफ द डेटा, ओके, जिसको आपको ट्रांसफ़र करना है उसका साइज क्या है. ओके, एड्रेस रजिस्टर मीन्स उसका एड्रेस क्या है, किस एड्रेस पर आपको ट्रांसफ़र करना है. एंड द सी आर कंट्रोल रजिस्टर मीन्स कंट्रोल करता है. ओके, कंट्रोल करता है. सो ये जो एड्रेस रजिस्टर है, तो इनिशियली एड्रेस तो इसके पास आ गया, और जैसे ही वर्ड काउंट करेंगे तो हर एक वर्ड बाय वर्ड भेजेंगे. सपोज ये आपका 20 वर्ड्स का डेटा है, तो वन वर्ड बाय वन वर्ड वी सेंड टू द मेमोरी, राइट, वी ट्रांसफर टू द मेमोरी. तो हर बार क्या होगा, ये एक इंक्रीमेंट होता रहे. प्लस 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 मीन्स इंक्रीमेंट बाय वन. ओके, एंड जब ठीक है, and so the register, okay, this is not plus plus, but when it transfer, like we have the 20 words to be sent, so after one word it will be decremented. So sorry for that, it will be incremented. And the address register is which is basically incremented. So sometimes they can ask you in the questions that in DMA the address register is incremented and the word count register is decremented by one. Why? Specify the reason. So the reason is that because as we know in memory we have various blocks, right? Various blocks, and this is divided into blocks, and each block has an address. So if we have 20 words, so one word is already, right, is stored there, and one is there. So after each transfer we have to increment the address. So initially we have address 0, and then we have address 1, address 2, address 3, address 4. This is like, okay, so that's why the address register is incremented by 1. So I have specified plus plus. Plus plus means increment by 1. And word count register, obviously the size is decremented each time a word has already transferred. So when I have transferred the one word, so I have left with the 19 word, and then at the next address we have stored the next word, so we are left with the 18 word. So what is the summary? That address register is incremented and word count register is decremented at each step. So this is your DMA. So it means when I look back to the definition, is that memory is accessed directly by the IO devices without the intervention of CPU, because as in the diagram we can easily see and look for that CPU is holds for the some time. CPU अपना काम नहीं करता है कुछ देर के लिए क्या होता है, कंट्रोल किसको दे दिया जाता है, आईओ डिवाइसेस को, कि वो कंट्रोल करें. ठीक है, और जब ये सारी चीज़ें हो जाती हैं तो जो DMA है वो उसको बता देता है. ठीक है, एंड देन इट्स completes the memory transfer, right? So this is the whole concept of DMA. So I hope that it is very useful to you, and let me know if you can understand these concepts clearly. Okay, so I will meet you in the next video in which I will explain the input output processor, and along with some numericals that has been asked in your exams. So thanks for watching. Thank you very much.